morning, students. Today is going to be the 20th session in the e-content series, and we are almost in the completion of the second chapter, that is coordination chemistry. In this class, we are going to deal with the drawbacks of valence bond theory and study the IUPAC system of nomenclature of coordination compounds. So first, let us discuss the drawbacks of valence bond theory. Valence bond theory cannot explain in detail the magnetic properties of the complex compounds. It cannot explain the optical absorption spectra of coordination compounds. It gives no information about the quantitative and thermodynamic stability of coordination compounds. It cannot predict properly whether a particular 4-coordinate complex is a square planar or tetrahedral in nature. It fails to make distinction between strong and weak ligands. Coming to the IUPAC nomenclature of coordination compounds. Let us first see the rules involved or applied while writing the formula. First, let us see how are we going to write down the formula and what are the rules applied here. The central atom is first listed. The ligands are then listed in the alphabetical order. The placement of the ligand in the list does not depend on its charge. Polydentate ligands are also listed alphabetically. In case of abbreviated ligand, the first letter of the abbreviation is used to determine the position of the ligand in the alphabetical order. In case of polydentate ligands are also listed alphabetically. In case of abbreviated ligand, the first letter of the abbreviation is used to determine the position of the ligand in alphabetical order. The formula of the entire coordination entity, whether charged or not, is enclosed in square bracket. When ligands are polyatomic, their formulas are enclosed in the parenthesis. Ligands abbreviations are also enclosed in the parenthesis. There should be no space between the ligands and the metal within a coordination sphere. When the formula of the charged coordination entity is to be written without that of the counter ion, the charge is indicated outside the square bracket as right superscript with the number before the sign. For example, we are going to write down the number before the sign of the complex. Let us here, I am going to write the number before the plus sign. The charge of the cations is balanced by the charge of the anions. The rules which are used while naming the coordination compounds. Now let us see the rules which we are going to use while naming the coordination compounds. The cation is named first in both positively and negatively charged coordination entities. The ligands are named in an alphabetical order before the name of the central atom or ion. This procedure is reversed for writing the formula. The names of the anionic ligands end in O. Those of neutral and cationic ligands are the same except aqua for water, amine for NH3, carbonyl for CO, and nitrosyl for NO. While writing the formula of the coordination entity, these are enclosed in the brackets. Prefixes mono, di, tri, etc. are used to indicate the number of individual ligands in the coordination entity. When the names of the ligands include numerical prefixes, then the terms bis, tris, tetrakis are used. The ligand to which they refer being placed in the parenthesis. For example, here already there is going to be a triphenyl. In such case, I am going to use as bis. So the name of this compound is going to be dichloro. It is going to be dichlorido bis triphenyl phosphine nickel 2. The oxidation states of the metal in cation, anion or neutral coordination entity is indicated by a Roman numeral in the parenthesis. If the complex is a cation, the metal is named as the element. For example, cobalt in a complex cation is called cobalt and platinum is called platinum. If the complex ion is anion, then the metal ends with the suffix ate. If it is going to be anion, then it is going to end with the suffix ate. For example, in the cobalt complex anion, it is called as cobaltate. For some metals, the Latin names are used as complex anions. For example, in case of iron, I call it as ferrate. The neutral complex molecule is named similar to that of complex cation. Let us see some examples. For naming the complex. Now this complex has got ammonia molecule, water molecule, chloride, ion. That is, it is going to be present as a ligand and outside the ligand. So it is going to be named as. First we are going to write down the cation and then the anion. And the ligands are going to be named according to the alphabetical order. So it comes to be tetraamine. It is going to be tetraamine, aqua, chlorido, cobalt 3, chloride. Another example. In this case, it is going to be named as first the cation and then the anion. In this case, because this is going to be an anionic complex, it will be named as, while naming always the positive ion is named first and the negative ion. So it is going to be potassium tetrahydroxidozincate 2. It is tetrahydroxidozincate 2. Coming to another example. In this case, I have got, this is going to be a cationic complex. I have got 3 ammonia molecules, 3 water molecules, and it is going to be named as triamine, triaqua, chromium 3, chloride. Now let us see another example. In this case, what do we have is, we are going to have, already it is going to be a diamine. So it is going to be named as tris-ethane, 1,2-diamine, cobalt 3 sulfate. Okay students, this is all about in naming of coordination compounds and the drawbacks of valence bond theory. Thank you.